right, so let's dive into some technical particulars, hopefully with somewhat of a softball question. HTTP. The goal of today is simply to give us a mental model for the types of applications and projects we're going to be implementing. On Wednesday, we'll transition in more depth to things like MVC, and particularly to Laravel and an ORM with which we'll talk to a database. But for today, let's set the stage for those conversations. HTTP is what? Hypertext Transfer Protocol. OK, what does that mean? Yeah. Oh, OK, close. It's the other one. Not HTTP. That's HTML. HTTP is the one that does what exactly?
Is it the service that transmits text back and forth between servers?
Yeah, exactly. It's the service. Or really, it's the protocol. It's the set of conventions that are used to transmit information back and forth between client and server. And that information usually takes the form of HTML, hypertext markup language, which is the open tags and closed tags. So if you do have some client represented here on the left and some server represented here on the right, the arrows going back and forth between them represent that language, HTTP. And if familiar with 50, for instance, last year or a couple of years ago, you might recall that we describe it as a protocol in the sense that when I first meet someone, I might extend my hand and say hello, and you might say hello. And now that sort of transaction between client and server is complete. All right, so HTTP is just a set of conventions, and among those conventions is to send certain messages. So for instance, let's open Chrome. And for the course, you can certainly use most any browser, but Chrome tends to be probably the most popular these days because it has a whole suite of tools built in. Let's go ahead and inspect element. Let me go to the Network tab, and let me go to something like http://www.cs164.net and hit Enter after first hitting record in case we get redirected. And now we're going to see a whole bunch of rows in this table. What does each of these rows represent when you visit a web page? Yeah? Exactly. All of the files I just requested are shown as an individual row in that little table there. But wait, files. I only requested one such file, right? Presumably index.html or index.php. They can be linked, right? Certainly, there's image tags inside of there. There's link tags for CSS. There's script tags for JavaScript and a whole bunch of other tags that might actually pull in additional files sort of recursively. And so that's what we're seeing. If we scroll up now to the very top of these, notice that we first see one that's actually kind of curious. It says our website moved temporarily. The status code, so to speak, is 302. There's another similar one, 301, which is moved permanently. And if you move temporarily or permanently, what does that mean? What should your eyes be looking for in order to answer where did we move to? Current link. OK, so we could certainly infer where we ended up. And apparently, I ended up at canvas.harvard.edu/something, which is a lot harder to remember. But more technically, I want to diagnose a redirect issue. I want to understand where I'm going from point A to point B to point ... canvas.harvard.edu. In this more arcane interface of headers, how do I answer a question of the form to where did I move? Oh, location. All right, so if I scroll down here to the response headers, notice that these are the headers. And let me change it. This is sort of a pretty printed version from Chrome. Let's click View Source. This is the raw text that the Apache web server, and I know that by glancing at this line here, and Apache is just free and open source software. It's probably the most popular web server software out there. That is the result of the handshake coming back to me. And if I sort of look at what was inside of the hand, or the virtual envelope that represents the packets going across the wire, inside of that is these several lines of text. And because browsers themselves speak HTTP, they are pre-programmed by Google and Microsoft and other companies to look for this line. And when it sees location : what does it do with the URL after the colon, presumably? It goes to it. And we can see this in any number of ways. In fact, a very handy tool, particularly on Linux and Mac OS, is if I open a terminal window here and I do curl, and I do -I, and then paste that URL there. It's a good habit to use quotes, because if you ever have question marks or other funky characters, you can actually sort of confuse the command line. But if you quote the URL there, now we'll see exactly all of the headers that came back. And in this case, actually, I did the wrong one. I did the canvas URL. Let's do http:// www.cs164.net, enter. There are exactly those same headers. And if I want to see next what comes back, I can just do this manually. So curl is just kind of a quick and dirty diagnostic tool here. Curl-I, and now that URL again. And these are all of the headers that now come back from canvas.harvard.edu. What additional information are they sending us? It's a little cut off. Let me move this over. So what of these lines is interesting? So content length, that's how many bytes were inside of the virtual envelope that came back. Content type, it's HTML. It might be something different if it's a PNG or a GIF or a JPEG. In fact, generally speaking, what is this string called? There are these unique strings in the world that uniquely describe different data types. This is a so-called MIME type, M-I-M-E type. So the world has standardized that .png, I think, is quote-unquote image/PNG. The world has standardized that an HTML file is text/HTML. The world has standardized that an MP4 movie file is video/MP4. So these are the unique tokens that browsers usually use to determine whether to play it as a movie, to display it as an image, to render it as HTML, or the like. What server does Instructure, the company behind Canvas, apparently use? So Apache, too. So they're using the same tool, and we can see that via this line here. As an aside, they've actually done something that's smart, that not all websites do. Very often, websites spit out not only that they're running Apache, but also that they're running Apache version 2.1.3. But these guys have been smart and disabled the version number. Why is that smart? Yeah?
Maybe because certain versions might be discovered to have particular vulnerabilities since it's not as obvious.
Exactly. It's a potential security threat. If you're essentially broadcasting in the world, hey, we're running this version, hey, we're running this version, it's not that hard with Google or with just curl even to poke around random IP addresses and find people running buggy software and then attack them via whatever documented means there are. Now, why is it still saying Apache? Arguably, that is sort of gratuitous information. Well, Apache makes it easy to turn off the version number, but not their sort of behind-the-scenes branding in this way. And this is how Google and other companies know what web servers people are running, because they are just telling the whole world every time you visit them. So cookies we'll come back to, but you may recall that cookies are sort of big, unique numbers that are typically like a hand stamp on the user. It's a little file or piece of data planted in the browser to remember who the user is. Status 200 is good. X canvas meta, so what is all of this? Well, long story short, the world has also allowed the world to come up with arbitrary HTTP headers, and if you prefix them with X, that just means they're custom, and it's a nice way, even for diagnostic purposes, if you are developing a web-based application and you want to be able to see behind the scenes, what backend server spit out this reply, or what version number is being run on this server, or what's its internal IP address, anything where you might want some internal glimpse at something that's going on, you can spit out your own arbitrary HTTP headers in that way. But the story began with opening up the course's website, and we saw all of these rows in the network tab. The first one was of most interest. That redirected us to the next, and then we got back to this response here. So where is canvas.harvard.edu? Let's push a little further and sort of follow these breadcrumbs. Canvas.harvard.edu is apparently owned by Harvard. They created this subdomain called canvas.harvard.edu. How would I figure out where in the world canvas.harvard.edu lives? Or maybe more specifically, what's its IP address? How can we figure that out? Yeah?
Aren't there like command line tools that can trace like all the different like IP addresses for different maybe like routers that pass through and you can see the end ways?
Absolutely. So that's actually an answer to a couple of questions there. The first such simple tool would be something called NSLOOKUP, though it's called other things, name server lookup. And I can type in something like canvas.harvard.edu, enter. And this is going to give me back apparently a whole bunch of answers, but let's see if we can't make sense of this. So apparently canvas.harvard.edu is a canonical name for this atrocious looking thing, harvardvanity.instructure.com. So what's going on here? Well, meanwhile, if we keep reading, harvardvanity.instructure.com has a canonical name of something even more cryptic, harvard-170 something-US East 1-ELB.amazon.aws. Moreover, that thing resolves to apparently 3 different IP addresses. So what in the world does all of this mean? Yeah.
So that is apparently the Amazon CDN, content delivery network, that is like getting bigger. That is delivering the content.
Okay, good. And let me tweak one thing that you said. It's not really a content delivery network. It's typically, that means it's static content. And because most of the website is dynamically driven, I wouldn't describe this as a CDN, but it is Amazon hosted servers. Amazon offers a service called Amazon Elastic Compute Cloud, EC2 for short. And these are just web servers, often running Apache or other pieces of software that you can rent, essentially by paying Amazon a few cents or a few dollars per hour, and actually run your code on their servers. And the means by which they do this is they give you a cryptic-looking domain name like this, which in turn resolves to one or more IP addresses like these three here. And in turn, you can create aliases that are a lot more human-friendly for that otherwise completely unmemorable Amazon address. And in this case, the company Instructure decided to create a slightly more memorable address, harvardvanity.instructure.com. But that would be an atrocious sort of thing for us to visit for course websites. So Harvard, in turn, created another alias that's more simply canvas.harvard.edu. And all of these techniques are leveraging something called DNS, the domain name system. And so long as a system administrator has access to Harvard's or Instructure's DNS servers, you can create these aliases. And if you guys, for your projects, decide to buy a domain name for $5, $10, or whatever, and even pay for a web host or just use a freely available web host, and you want it to actually live not at something random.com, but at your own domain name that you bought for $5 or $10, these are the kinds of configuration details that we'll explore toward the end of the semester if and when it comes time to ship something publicly, so it can live at a more interesting URL. Let me pause for a moment, because you guys are sort of unnecessarily bunching up in there. Do you want to awkwardly just kind of come in and sit in the back or in the middle? Should I not draw attention to you? Come on in. That's probably more uncomfortable there. All right. OK, welcome. All right. So where does that now leave us? So somehow or other, and we'll cross this bridge if and when the time comes in terms of DNS, how you would actually configure all of that, somehow or other, this HTTP request, this initial handshake, reaches a server at one of those IP addresses. On that server is something called a web server. No surprise. But what truly technically is a web server? We sort of take the phrase for granted, but what is it? What is a web server? Yeah?
It's just a computer with like memory and processors.
OK, so it's just a computer with memory and inputs. You know, it might have looked like that picture earlier, even though this one's a little retro and more of a desktop or tower computer. But yeah, it's just a computer. But technically, a web server isn't a computer per se. We as sort of humans have long conflated web servers and email servers as physical devices. But a web server really is a piece of software. It's a piece of software running on a physical computer. And therefore, you can have an email server and a web server and a chat server and any number of other servers, or more properly services, running on top of a particular computer. And all of those services can live at the same IP address, therefore. So how, if you do have multiple services or servers running on the same computer, how, when zeros and ones are coming in at them via the internet, does the computer know whether to respond as an email server, with a web page, with a chat? Yeah?
I think that a web server is like, it's like a piece of code that sits on port 80 and listens,
Good.
and then responds to the people that ping it.
Exactly. So a web server listens on what's called a port. And if you've taken CS143 networking, you might know that these ports relate to protocols like TCP, which you've probably at least heard of, or UDP. And these ports, or port numbers, are just unique identifiers that identify a service. So 80 is web, 25 is email, 23 is telnet, 22 is SSH. And there's dozens or hundreds of other ones, although there's just a few very popular ones. And this is one way for a computer with one IP address to sort of multiplex among different types of requests and respond accordingly. So what does this actually mean? So we don't need a web browser. We don't need curl to actually talk to a web server. We just have to understand what the protocol is and how it works. And I alluded to this a moment ago. Telnet is sort of an old school program. Back in my day, we used to use it to check email, but it was completely insecure. It's just a tool via which you can send textual commands to another computer. And back in the day, those textual commands often included your username and your password with no sort of encryption. If you're familiar with SSH, SSH is pretty much Telnet, but with encryption. So that's a bit of an oversimplification. But I can pretend as a human with a terminal window in this old school program Telnet to be a web browser. I can type in something like telnet www.cs164.net. And unfortunately, if I just hit enter, it's trying, but nothing seems to be happening. And that's because by default, the world decided years ago that Telnet's default port is 23, as I briefly alluded to a moment ago. But I don't want Telnet per se. I want to use Telnet, this sort of textual program, to pretend to be a web browser. And Chrome and IE and other browsers, by default, have been hard-coded by Google and Microsoft to talk not to 23, but to 80, or maybe 443 for SSL-based websites. And now, notice I try and I connect to the web server. I'm going to now go ahead and say something like hello. And apparently, this is just moved permanently. I sent some bogus command, and it's sending me back to this address here. So let's actually do this a little differently. Let's actually say get/http/1.1. So what am I doing? This is the command. This is sort of my handshake, so to speak. What does the / probably indicate? The home directory. So the home directory here just means, well, let's call it the root of the website, whatever the default file is. Maybe it's index.html, maybe it's index.php. And http/1.1 is essentially the latest version of HTTP. So I'm pretending to be a browser that's pretty current so that it responds to me as I hope. And I go ahead and hit enter twice because the way things work is that once you see a blank line, does a web server then respond? But unfortunately, this is a bad request. The browser sent a request that the server could not understand. Now, this one's a lot harder to diagnose, but it turns out that CS164.net is using Apache, and that much we can figure out. But it's also using something called virtual hosting, with which you might be familiar, maybe vaguely from your CS50 days or if you've written commercial websites before. What's a virtual host or vhost? Yeah.
So the idea is usually when you hit a machine, it has a particular IP. And if you want to host multiple websites, for example, on that one like Apache instance, the idea is to assign based on what namespace is being requested.
Okay.
Serve up a different page.
Exactly. So there's multiple layers of multiplexing here, so to speak. When you get a request at some server at a particular IP address, you minimally need that port number so that the server knows is this an email, is it a web request, a chat message, or whatnot. But if once you figure out, OK, it's port 80, it's obviously a request for a web page, but wouldn't it be nice if a single server could actually support multiple websites, foo.com and bar.com and baz.com, so they don't need one physical server or one single piece of software for every damn website in the world. So the world invented virtual hosting, which allows you to put multiple domain names on the same IP address. But the catch is, the connection I just made using Telnet, specifying port 80 to www.cs164.net, I made no mention of the domain name that I was interested in beyond the command line. And unfortunately, and this is a little non-obvious, as soon as I hit enter, essentially Telnet presumptuously is converting www.cs164.net for me to an IP address and then just sending my raw GET request to the server. So that notion that it was www.cs164.net, completely lost, right? Telnet is not a browser. Why would it bother sending additional information to the server? It's not that smart. So I, the browser, have to remind the server that not only do I want to get the home page, I also want to specify a host of cs164.net. And the HTTP header, so to speak, is exactly that, host : Now, when I hit enter, I get back the same redirect that I saw in Chrome and that I saw in curl. But I dare say now we are doing this just about as low level as is technically possible by using these more arcane commands. Now, why is this useful? So this is not the normal way to visit a website, but almost any time you have to diagnose some problem with a web-based application that involves a server or a piece of software or newly created virtual host or a newly bought domain name, these are exactly the tools that Tim and Rob and I and others would use just to try to figure out what's going wrong. Right? Case in point, anytime you get a domain name, you somehow have to associate an IP address with it. And you do this typically via a web-based interface at GoDaddy or Namecheap.com or wherever you bought the domain name. So different websites have different tools, but it's essentially an Excel table with columns for the host names and columns for the IP addresses, something like that. But there's a problem because anytime you're asked to associate an IP address with a host name, you are asked for its TTL, which stands for, if you took 143, I hear it over here. Time to live. A TTL means how many seconds should this entry be remembered for. And by remembered, I mean cached. So long story short, also within the DNS world, there's this whole notion of caching. And this is a topic we'll explore in the course as well at a software level, whereby caching is often a really good thing. And what do we mean by caching a web page, for instance, or caching a DNS record, an IP address? What does that mean, to cache? Yeah. Yeah, exactly. Just keeping around a copy so that if it doesn't change, or frankly, even if it does change, let's not notice for at least a few seconds, maybe even a few minutes, or worse, for an hour or two. And in a website, you might have seen this before. Sometimes if you're using a website, not so much the biggest websites who tend to get this detail right, like Facebook and Gmail and the like, but if you're using another website that is using a lot of the technologies we'll use in the class, it's often a design decision to decide whether or not to cache something, and if so, how long to cache something. And if you've ever been to a website where, for instance, you hit save, and then you reload the page, and then whatever you posted isn't there, but then maybe you reload again, and it appears. And in fact, I've actually seen this symptom even with Facebook once in a while, where if you reload your news feed, sometimes something's there, sometimes it disappears, and things don't really seem consistent, and that's often the result of just caching issues. On one request, you're hitting one server. On another request, you're hitting another server, and their caches, their copies of web pages might not be perfectly synchronized by a few seconds or minutes, so you see different states of the world. Same thing happens with DNS. If you decide that you own foo.com and you've been hosting it at GoDaddy, a fairly popular web hosting company, among others, and you decide, no, I don't really like their politics, I don't really like their prices, their services, I want to change to another web hosting company altogether, what do? Well, you just simply change the IP address of foo.com to point at someone else's server who you're going to start paying money to. But because the whole DNS server system uses caches, what might this mean for your users if suddenly you move your website from here to over here, a different IP address? Right? For some non-zero number of minutes or seconds, your users might end up going here, for instance, or here, because their operating system, their browser, their ISP, their home router might have cached the old IP address, at which point it's really hard to figure out exactly what's going wrong. So how do you start to chase down even issues like that? By just following these breadcrumbs and understanding ultimately what is HTTP and what does it mean to send a request and what do tools like NSLOOKUP actually do for you. And so how can you execute some of these low-level commands and just figure out what in fact is going wrong so you know who to call, who to send off an email to, or what to change on your own server. And as an aside, I'm guessing most of you here have used the CS50 appliance. If you did take CS50, even if you didn't, many of you have probably used Apache, whether on your own Macs or PCs or Linux boxes. Just as an aside, if I do open a terminal window here on the latest CS50 appliance, and I become root with sudo su, and then I go into this directory here, etc httpd conf.d, this is a common place for for Apache web servers to store their configuration files. Conf.d just means configuration directory with a whole bunch of files. And if I open up with VI, for instance, appliance 50, you'll actually see how virtual hosting in the CS50 appliance has been working all this time. If it's been a while, recall that you can put most any website inside of your vhosts directory in the appliance. How does that actually work? Well, notice this is a bit arcane, and you could sort of grok your way through this using the documentation. But essentially, probably the most useful line to look at is this. this line here essentially tells the web server to look in John Harvard's vhost directory for the lowercase version of whatever server name or domain name was actually visited. And we won't necessarily go into this degree of tinkering, but when using Apache, you are the ones who ultimately have control over those details. Whew. OK. So henceforth, we can now take HTTP for granted, right? All right. So why don't we do this, especially if some of you feel somewhat of a captive audience? Why don't we go ahead and take a 2-minute break? When we come back, we'll dive a bit into MVC, and we'll end on a note of a problem that we will then solve on Wednesday with a tool called Laravel. So let's take a couple minutes.